In Lesson 2.4, we're going to solve rational equations. Rational equations contain at least one rational expression, which is just a fraction with a polynomial in the numerator and a polynomial with a degree greater than 0 in the denominator. An easier way to say that is that we have our variable that we're trying to solve for in the denominator of at least one of the fractions in the equation. Look at example 1. We want to solve this for the variable k, which is in the denominator of the fraction on the left side. So we have to get that k out of the denominator in order to solve for it. If I can read this 2 over k, which means the same thing as 2 divided by k. So to get rid of divided by k, I'm going to multiply both sides by k. Now on the other side, I have 4 over 9, which is also read 4 divided by 9. So to get rid of that 9 in the denominator, I'm going to multiply both sides by 9. Now remembering that we can multiply in any order, on the left side, I'm going to look at this k over k, and I can cross it off because k over k is just 1. And that leaves me 9 times 2, which is 18. And on the right-hand side, again, I can multiply in any order. So I'm going to think of this 9 over that 9. They cancel each other out because 9 over 9 is equal to 1. And that leaves me 4 times k. Now I can divide both sides by 4 to get k by itself. And k is equal to 18 over 4, which simplifies to 9 over 2. And that's the number that solves this equation. I want to go through this problem again and streamline the work for you a little bit so that when our expressions get a little bit more complicated, we can follow the process without making our work so messy. So when we multiplied both sides by both denominators, on the side where the variable was, it canceled out because it was a factor of 1. And on the other side, we had this cancel out because it was a factor of 1. So let's see how we could do that without writing so much work down, without having to cross those off. What if we multiplied this denominator times that numerator? K times 4 is 4k. And let's multiply this numerator by that denominator. Now notice we're doing that across an equal sign. 2 times 9 is our 18. Don't forget the equal sign between them. So what that does is it saves us from writing this factor of 1 right here and writing this factor of 1 right here. But you see we get the same result. 2 times 9 is 18 is equal to 4 times k. And then our problem looks the same right there, but we haven't had to write down so many steps. Now let's use that process in our next example. In example 2, I have 7 over 3 is equal to 8 over r minus 4. So my rational expression is in the denominator on the right-hand side. So I'm going to use this shorthand process of simplifying. I'm going to multiply both sides by 3, but I'm only writing the 3 on the right side. I'm crossing it off on the left, and I'm writing it on the right side. I want to get rid of r minus 4, so I'm going to cross it off, and I'm going to write it on the other side of the equation. Now the fraction bar groups it in the original fraction, but since I'm taking it away from the fraction, I have to make sure that I group those terms together in parentheses. So that's the shorthand way to write your work. Now we want to get rid of this group by distributing the 7 through the group. So I have 7r, and then 7 times negative 4 is minus 28. Don't forget your equal sign, and 8 times 3 on the other side is 24. Now let's add 28 to both sides, which gives us 7 times r is equal to 52. Divide both sides by 7, and r is equal to 52 over 7. And that's our answer. Now let's go back to this idea that some variables may have to be excluded because they make the denominator equal to 0. Let's talk about fractions for a minute. If I have a fraction like 0 over 5, then that's just equal to 0. A scenario to describe that is that I have a pizza that's cut into 5 pieces, but I don't feel like eating pizza today, and so I don't take any of the slices. I take 0 out of the 5 pieces of pizza, so I don't have any. But if I turn that fraction upside down and write the 5 on top and the 0 on the bottom, that would indicate that I have 0 pieces of pizza, but I'm going to eat 5 of them. And that just doesn't make any sense at all. So when we get a fraction with a 0 in the denominator, we call that undefined, because it just doesn't make any sense mathematically. So when we have a rational expression, we have to think about that. What would make this rational expression undefined? In other words, what would make this denominator equal to 0? And it can't be 0, so we'll say r minus 4 cannot be equal to 0. We can solve this inequality the same way that we solve an equation. Add 4 to both sides, and r cannot equal 4. But r is not equal to 4. R is equal to 52 over 7, so it's okay. This is a valid solution. But we always have to check that when we have a rational expression. In example 3, we have 2 rational expressions, so we have to check both of them for excluded values. You can check for excluded values before you start solving, or you can check them later. Let's go ahead and check to see what would make this first denominator equal to 0. In other words, let's say that h plus 10 cannot equal 0. Subtract 10 from both sides, h cannot equal negative 10. Let's do the same thing for the other rational expression. H plus 7 cannot equal 0 because it's a denominator. Subtract 7 from both sides, h cannot equal negative 7. So these are our excluded values. They're not our solutions. Now let's go back and solve this rational equation. So to get rid of this denominator, I'm going to multiply the other numerator by h plus 10. And to get rid of this denominator, I'm going to multiply the other numerator by h plus 7. Let's distribute the 6. 6 times h plus 6 times 7. Let's get rid of these parentheses on the right side by distributing 3 times h plus 3 times 10. Now we want to collect our h's on one side and our numbers on the other side. Pause the video while you do that and then come back and check your answer. So after you solve, you find that h is equal to negative 4. Since that's not negative 10 and not negative 7, that checks out. That is a valid solution. Example 4 looks a little different because we don't have a fraction on the right-hand side of the equation. But remember, we can always make a number into a fraction by writing it over 1. That doesn't change the value of it. It just makes it look like a fraction. So now we can use our strategy from the previous examples. We can get rid of this denominator by multiplying 1.4y by the other numerator. And we can get rid of this denominator by multiplying the other side by 1. Of course, multiplying by 1 does not change the value, so I still have 65 is equal to, distribute the 5. 5 times 1 is 5. 5 times 4y is plus 20y. Subtract 5 from both sides. Divide both sides by 20. And we get y is equal to 3. Now I did not check for excluded values at the beginning of solving this problem, so now I need to check this answer and make sure that it doesn't cause me to be dividing 65 by 0. So I could take the 1 plus 4y and say it does not equal 0 like I did before, or I can just substitute the 3 in for the y and see if I get a 0. So 1 plus 4 times 3 is not equal to 0, which means that this value is okay for a solution. Part of the challenge in algebra is to take an expression that looks a little bit different, or an equation that looks a little bit different, and figure out how to make it look more familiar. So on example 5, you see that we don't just have our rational expression, which is the fraction, we also have this number that it's subtracted from. That looks different from our previous examples. So let's get rid of this thing that's making it look different. Let's get rid of the 10. Remember, this is a plus 10. It comes first, but it's just added to the fraction because it's a positive 10. To get rid of plus 10, we're going to subtract 10 from both sides. 15 minus 10 is 5. And then we're going to take this negative, and you can move it to the top or you can move it to the bottom, or you could even divide both sides by the negative. But the easiest thing to do is to take it into the numerator, not because it's the numerator, but because it's just a simple number up there. So we can call that negative 70 divided by 4 minus 2x. Now remember to think of that 5 as 5 over 1, and then we can get rid of the 1 by multiplying the other numerator by 1. We can get rid of the 4 minus 2x in this denominator by multiplying this numerator by 4 minus 2x. Get rid of the grouping by distributing the 5, so 5 times 4 is 20, and 5 times negative 2x is negative 10x. And negative 70 times 1 is negative 70. Now let's remember this is a plus 20, so we're going to subtract 20 from both sides. Negative 10x is equal to negative 90. Divide both sides by negative 10, and x is equal to 9. Now we can check and make sure that that doesn't give us a 0 in our denominator. If we take 4 minus 2 times 9, then that's 4 minus 18, which is definitely not equal to 0. So this number checks out. On example 6, I have 4 divided by x plus 3, so I want to get rid of this denominator by multiplying the other numerator by x plus 3. I want to get rid of this denominator by multiplying the other numerator by 3 plus x. Now I want to distribute to get rid of the grouping, so 4 times 3 is 12, and 4 times x is plus 4x. And on the other side, get rid of the grouping by distributing 8. So 8 times x plus 8 times 3. Now we want to collect our letters on one side, so I'm going to subtract 4x from both sides. And I'm also going to subtract 24 to get the numbers on the other side. So this is a 0, and this is a 0. I wrote that on one line. You can separate it into 2 lines if you want to. So my number parts are going to simplify to negative 12. And my variable parts are going to simplify to 4x. Now I can divide both sides by 4, and I get negative 3 is equal to x. Now this is my solution, but remember I have to make sure that it doesn't cause either of those denominators to be equal to 0. And you may have noticed in the beginning that our denominators here are actually the same, because we could use commutative property on x plus 3 and call it 3 plus x, so those are the same. So if we take x plus 3 and say that cannot equal 0, then we find that x cannot equal negative 3. But that's what we found to be our answer, and that's the only possibility for our answer, but it's excluded, so we have to say nope, that will not work, and this would be no solution. Pause the video and work the last problem, and then come back and check your answer. Take some time to review the work. Ask questions if you have them. We get to an answer of x is equal to 3. Don't forget to check this. If you didn't check for excluded values to begin with, check it at the end, but we see that 3 is not an excluded value, and so it's a valid answer.